Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Saya daripada kumpulan Math Avengers akan membentangkan tentang thermal expansion of a piston rod dengan menggunakan kaedah arithmetic dan geometric sequence. Sebelum kita ke fokus utama kita, saya akan memperkenalkan dahulu ahli kumpulan kami. Saya, Zuhair Hakim, bersama-sama Syakif Amsyar, Fitri Danish, Jacqueline dan juga Adrini. Baiklah, untuk penyataan masalah kami, piston rod dalam internal combustion engine mengembang dan mengecut akibat pemanasan dan penyujukan berulang setiap kitaran semasa beroperasi. Pengembangan berlaku secara beransur-ansur kerana pendedahan haba dan kelemahan bahan. Jika panjang rod melebihi had selamat maksimum M, ia boleh menyebabkan kegagalan mekanikal dan kerosakan enjin. Arithmetic sequence digunakan untuk memodelkan pengembangan linear iaitu peningkatan berterusan setiap kitaran, manakala geometric sequence pula digunakan untuk memodelkan pengembangan berkadar iaitu peningkatan perkembangan dengan nisbah yang tetap. Kajian ini bertujuan untuk meramalkan kitaran di mana rod menjadi tidak selamat untuk digunakan dan membandingkan kedua-dua model.
Assalamualaikum, my name is Shakif Amshar Mashahrizan, metric number AA258-863. Today we are analyzing a critical mechanical issue involving a piston rod in an engine system. Based on our observation, we have identified 4 key facts. First, the piston rod undergoes repeated thermal expansion and contraction during every operating cycle. The rod starts with an initial extension of 1 mm. Crucially, with every cycle, the rod expands further due to a combination of heat and material fatigue. Finally, there is a maximum safe limit. If the extension exceeds this limit, the rod will fail, potentially causing catastrophic damage to the entire engine. Second one, propose idea and models. To manage this risk, we propose using mathematical models to predict when the rod might reach its failure point. We are looking at 2 specific approaches. First, arithmetic model linear. This assumes the rod extends by a constant amount each cycle due to uniform heating. Second one, geometric model proportional. This assumes the extension grows by a fixed percentage because higher temperature accelerates material fatigue over time. The third one is learning issues. To move forward, our team needs to address several key technical questions. How can we accurately calculate the exact point where the expansion reaches limit? Second one, how do we effectively apply arithmetic and geometric sequence to represent linear versus accelerated expansion? What are the specific parameters for our initial length, common defense, and growth ratio? The last one is the action plan. Our roadmap to solving this problem consists of 3 main steps. First one, the technical study. We will master the formulas for the nth term and the sum of terms for both sequence type. Simulation, we will construct data table for 20 operating cycles using both Excel and manual calculation to compare the models. Execution tasks have been assigned across to the team for calculation, report writing, and data visualization. Our goal is to provide a clear prediction of the engine's safe lifespan. Thank you.
Assalamualaikum and hi everyone. My name is Fitri Danish Benusizam. My number matrix is 250181 and I will explain to you guys about how to calculate using arithmetic and geometric formula. So let's move on to solution for part A. The first question is derive the nth term formula, which is Tn, and sum of the nth term formula, which is Sn. So the Tn formula is A1 plus n minus 1 multiplied by d. Sn formula equals n divided by 2 multiplied by 2a plus n minus 1 multiplied by d. So apa yang korang nak kena tahu dekat dalam formula ni adalah apa itu value a, apa itu value n, apa itu value d. So a adalah sebutan pertama korang, n adalah sebutan keberapa yang korang nak cari, dan D adalah sebutan. Beza antara sebutan. Beza antara sebutan ni korang boleh cari menggunakan sebutan ketiga tolak sebutan kedua, ataupun sebutan kedua tolak sebutan pertama. Okay, so move on to the second question. We need to calculate some things. So the first things is the extension at cycle 15. The extension at cycle 15, kita kena pakai Tn punya formula. So kita masukkan nilai N, nilai A dan nilai D. Untuk nilai N kita kat sini adalah 15, untuk nilai A adalah 102.5 dan untuk nilai D adalah 0.6. So put all the value together in the formula. So we got T15 equals 102.5 plus 15 minus 1 multiplied by 0.6. So the answer is 110.9. So the second things that we need to calculate is the total extension after 15 cycles. So dia tanya total, jadi kita kena tambah. So equation yang berkaitan dengan tambah adalah Sn. So kita masukkan nilai N, A dan D kita dalam formula ni. Jadi kita akan dapat S15 equals 15 divided by 2 multiplied by 2A 2 multiplied by 102.5 plus 15 minus 1 multiplied by D. So the answer that we'll get is S15 equals 1600.5. The third question is the average extension per cycle up to 15 cycles. Jadi dia tanya average. Jadi kita kena pakai formula average. Formula average kat sini adalah S15 equals the total of extension up to 15 cycles divided by 15 cycles. So we got 1600.5 divided by 15 equals 106.7. So that is the answer for the third question. So the fourth question in question 2 is the first cycle end when Tn is bigger than M. So dia tanya bila Tn ni lebih besar dan sama dengan M. Jadi kita kena tukar Tn ni dalam bentuk equation A1 plus N minus 1 multiplied by D. Lebih besar daripada M. M ni adalah maximum value. Jadi kita akan dapat 102.5 plus N minus 1 multiplied by 0.6 lebih besar daripada maximum value kita, which is 111. Jadi kita cari nilai N dekat sini. So kita akan dapat N lebih besar daripada atau sama dengan 9.1 divided by 0.6. So jawapan N kita adalah 16. Now let's take a look at the question number 3 for part A. We need to construct a table for Tn and Sn value up to 20 cycle. So dalam soalan ni dia nak value Tn dengan Sn daripada sebutan pertama sampai sebutan ke 20. So untuk Tn ni kita orang just guna je Tn punya formula dan Sn pula Sn punya formula. So we got the Tn value at cycle 20 is 113.9. So for the Sn value at cycle 20, we got 2278. Let's see on the graph for T value. the graph is Tn versus n. We can see that the value is increasing at constant rate, and we got the perfect linear line for t value graph. Same goes with Sn graph. We have the perfect linear line and the increasing value at constant rate. Now, moving on to the second part, which is part B, a geometric sequence. So the first question is derive the n-term formula and sum of the first n-term formula. So dekat geometric sequence ni, korang kena tahu 4 formula utama, iaitu Tn sama dengan A darab R kuasa N tolak 1. Okay, so R ni apa? R ni adalah dia sama je konsep dia macam D, tapi dia bahagi. So contoh, sebutan kedua bahagi sebutan pertama, korang akan dapat R. Ataupun sebutan ketiga bahagi sebutan kedua, korang akan dapat nilai R. So untuk formula yang kedua ialah Tn sama dengan Sn tolak Sn tolak 1. So formula yang ketiga adalah Sn sama dengan A darab 1 tolak R kuasa N bahagi 1 tolak R jika R lebih kecil daripada 1. Untuk formula yang keempat adalah Sn sama dengan A darab R kuasa N tolak 1 bahagi R tolak 1 jika R lebih besar daripada 1. So, kita orang ada juga includekan formula ketakterhinggaan S, iaitu S infinity sama dengan A bahagi 1 tolak R. So, that is the final answer for the question 1. The second question is we need to calculate. So ada 4 benda yang kita nak calculate kat sini. Yang pertama adalah the extension at cycle 15, which is T15. So kita guna je formula yang pertama, iaitu formula Tn. Kita masukkan nilai A, R dan N ke dalam formula tu, dan kita akan dapat persamaan T15 equals 102.5 multiplied by 1.006 powered by 15 minus 1. So kita akan dapat value T15 kita sama dengan 111.45. Benda kedua yang kita nak kira adalah the total extension after 15 cycles. So we use the fourth formula, which is R kita lebih besar daripada 1. Sebab R kita adalah 1.006. Jadi S15 sama dengan 102.5 darab 1.006 kuasa 15 tolak 1 bahagi 1.006 tolak 1. S15 kita akan dapat 1603.78. Untuk benda ketiga yang kita kena kira adalah the average extension per cycle up to 15 cycles. So for the average formula, we use average equals Sn divided by n. So average equals 1603.78 divided by 15. So we got the value of average is 106.92. The last thing that we need to calculate is the first cycle n, when Tn lebih besar daripada atau sama dengan maximum value kita. So maximum value kita kat sini adalah 111. Jadi Tn tu kita tukar jadi formula dia, which is A darab R kuasa N tolak 1. So kita akan dapat A darab R kuasa N tolak 1 lebih besar atau sama dengan maximum value. So kita akan dapat N lebih besar atau sama dengan 13.321 plus 1. N kita lebih besar sama dengan 14.321. So kita punya nilai n value adalah 15. Now, moving on to the third question on part B, we need to construct a table for Tn and Sn up to 20 cycles. So for the calculation, we do it manually and we do the formula as the same as the second question. And we do it on Excel. So the value of T at the cycle 20 is 114. The Sn value at cycle 20 is 2171. For the last question of part B, we need to plot the graph on Excel. So we plot the graph first on Tn versus n, and the second is Sn versus n graph. So let's focus on the Tn versus n graph first. So we got not a very perfect linear graph, but you can see that T value is increasing at the constant rate. However, on Sn versus n value, we got the perfect linear graph and the S value is increasing at the constant rate. So that's all for the solution part. Moving on to the discussion. Thank you so much.
Assalamualaikum and good day everyone. My name is Nur Azrini binti Muhammad Aziz with metric number AA 250868. For discussion part of my presentation, based on the result, the geometric sequence model predict unsafe condition yearly that the arithmetic sequence. The piston rod exceed the maximum safe lead at an earlier cycle in the geometric model, indicating higher sensitivity to repeated heat exposure. In terms of growth rate, the geometric sequence show faster growth compared to the arithmetic sequence, while the arithmetic model increases at a constant rate. The geometric model increases proportionally, resulting in a steeper expansion trend. The result also show that heat causes the piston rod to expand progressively over time. The repeated heating cycle lead to an accumulation of expansion, which may eventually exceed the safe operating limit of the piston rod. Several factors may influence the result of the study, such as temperature variation, material properties, and assumptions made in the mathematical models. In real application, these factors may cause difference between theoretical prediction and actual behavior.
Good day everyone, my name is Jifina Najili and my metric is 88250159. Today I would like to present our conclusions for PBL Algebra. To conclude our project, we applied arithmetic and geometric sequence to model the thermal expansions of a piston rod due to repeated heating cycles. From our results, the arithmetic sequence shows a constant increase in piston rod length for each cycle, while the geometric sequence shows a faster and proportional increase. Based on the comparisons, the geometric model predicts unsafe conditions early than the arithmetic model, which indicates that it is more sensitive to repeated heat exposure. The findings also show that continuous heating causes the piston rod to expand progressively over time, and this accumulated expansion may exceed the maximum safe limit. Overall, this project demonstrates that how arithmetic and geometric sequence can be applied to analysis real-world engineering problem and help in understanding safety-related issues in mechanical system. Thank you. That's all from me.